I think we should use this as an opportunity to show off the power of Desmos, because even with something weird like absolute value, we can solve this without really much thought or much chance of error. So first thing I would do is I would type in the equation that I'm given, and I would use the f of x there so that I can use the function notation again later. So f of x is equal to, and the absolute value bars are there. They're right above that ABC button right there. So there's an A between them, so that's what we're going to type. And then x minus 4x, yes, we could combine those. That's fine, but I'm not going to bother because, why bother, right? I mean, we can just type it as is, and we get what an absolute value equation usually looks like in the xy plane is one of these v's. It kind of like bounces. So, okay, cool. And they want to know f of 5 minus f of a is negative 15. What value of a satisfies that? So again, sometimes with Desmos, just type what you're told, and you'd be surprised how well it works. So I think this is going to work. I hope so. So f of 5, which already it knows how to calculate because it's taking that 5. It knows to take the 5 and put it into the f of x that I told it. This is why function notation is useful, is Desmos can kind of communicate with the other lines and know how to kind of work things together. But let's finish with the job here. So f of 5 minus f of a. So let's go back to that f of a. And here we're going to have a problem. Yes, good. Is it doesn't know what the a is. Now, I think there's one thing I could do with Desmos, but I'm going to just stick with what's written here, right? Because I want this to equal negative 15. So if I hit this add slider, it's going to evaluate what I just typed, even though before it had an error. Now it's going to evaluate it because now I've told it that a is equal to 1. So what it's doing is it's doing f of 5 minus f of 1. It's reading the a, putting that in for the a in the f of a, and then because it's reading the f of x, it's able to put both the 1 and the 5 into the f of x and evaluate the whole thing without me having to think about it at all. So this is really cool. But I don't have 1 as a possible answer, right? They're saying what value of a satisfies it. 1 is not one of my answer choices. So I would just try my answer choices and we can just type them in, right? So I could use the slider and actually move it around, or I can just do what they told me. So let's just go in order, negative 20. And notice the value of f of 5 minus f of a changed. But I still didn't get what I want, right? I don't want negative 45, I want negative 15. So what I'm doing here is I'm just seeing, does this answer choice give me the number I want? So it's using Desmos, but it's also being kind of clever about like, okay, how can I maybe like almost work this backwards a little bit, and what's going to result in me doing the least amount of work, and letting the calculator solve it for me. So let's just continue. That's getting rid of choice A. Let's go back, and 5 is the next one. 0, and that shouldn't surprise us. F of 5 minus f of 5 is going to be 0, so that's gone. And let's try 10. And that's negative 15, so that seems to work. We could, for the sake of it, try 45, but it's not going to do it, right? That gives us negative 120, so there you go. That's it. So that's basically how I would do this. The only thing I might do differently is I am a little bit more traditional sometimes. I might have guessed and checked this more manually and just put in the 10 and kind of solved it myself. But, I don't think that's necessary. But just to show you what would happen, right? So how does that, basically let's use choice C to kind of remember how absolute value works, right? So if I wanted to, basically these absolute value bars do work like parentheses. So I could simplify these and get f of x equals x minus 4x. They're both in the parentheses. I can work that through. That's going to be negative 3x. And we still have those absolute value bars. Now, if you've learned absolute value, you might be tempted to say that the negative kind of goes away, because what do absolute value bars do? They turn negatives into positives. But we don't have a negative yet. We have negative 3x, but x, what if x is a negative number, right? That's going to affect things in different ways. And so we don't really want to make those absolute value bars go away until we have a number to put into the x and actually resolve the negative 3x. There are other things we could do, but basically for safety's sake, don't do anything with absolute value bars until you've got a number. That's kind of how we want to work it. So if I were to do f of 10, or let's do the f of 5, since that's first, right? So f of 5 would be the absolute value of negative 3 times 5. So that's the absolute value of negative 3 times 5 is negative 15. And now those absolute value bars can go to work. negative 15 becomes positive 15, right? So that's what's going on there. So that gives us that value. And then honestly, if I were doing this at Desmos, I would just guess and check. I would have a sense that probably, B isn't going to work because f of 5 minus f of 5 is going to be 0. That's kind of intuitive for me. I'd probably try 10 next anyway because it's kind of the easiest number. So let's just do that. F of 10 would be the absolute value of negative 3 times 10. So that's the absolute value of negative 30, which is positive 30, right? Because again, the negative becomes positive with the absolute value bars. And so now it's 15 minus 30, which is negative 15. That works out perfectly. That's more of how I would do this. There might be other ways that involve kind of weirdly substituting x minus 4x in for these f of 5s and things and kind of solving for a, but oh God, that sounds so, terrible, especially because absolute value has this weird behavior that just feels unintuitive sometimes. So I'd much rather have numbers. Numbers are better than algebra as much as possible on the SAT. But, try to work this into your system, right? I think we can't do stuff like this Desmos thing in school because we're forced to do it by hand. But you don't get extra points for doing it by hand on the SAT. So knowing how Desmos works, knowing what inputs you can have and how you can change values and things like that, all are really, really powerful. So that way you can kind of find that most efficient way to solve a question that reduces the chance of you making a mistake. What's the worst that could happen here is you type it wrong. So make sure you don't do that, and you can get this one pretty easily.